Yeah, hello everyone. So, in the last lecture we have seen that what is the existence theorem for Laplace transforms. We have seen that if a function is piecewise continuous and is of exponential order alpha, then its Laplace transform always exists. Otherwise, if function is not piecewise continuous or is not of exponential order, then Laplace may or may not exist. That also we have seen. So, now in this topic we will see what are the properties of Laplace transforms. So, we will start with the first property that we call as shifting property. Now, shifting property is first we have first translation and then we have second translation of the shifting property. What is first translation? First translation means if Laplace transform of f t is say f p, then if this holds, then Laplace transform of e ki power a t into f t is nothing but f of p minus a. That means, if you know the Laplace transform of f t, which is given as f p, if you know this, then Laplace transform e ki power a t into f t is nothing but you simply replace p by p minus a. So, then we will get the Laplace transform of this function e ki power a t into f t. Now, what is the proof of this result? So, how we will obtain this result? Now, what is Laplace transform of e ki power a t into f t? By the definition, this is nothing but 0 to infinity e ki power a t f t into e ki power minus p t d t. This is by the definition of Laplace transform. So, this is equal to 0 to infinity e ki power minus p minus a times t into f t dt. So, this is nothing but 0 to infinity. Suppose p minus a is some xi of f t, where xi is nothing but p minus a. So, then this quantity is nothing but f of xi, because what is f p? F p is Laplace of f t, which is 0 to infinity e ki power minus p t f t dt. So, instead of p we have xi in the same expression. So, we replace f by xi, and what is xi? Xi is p minus a. So, it is p minus a. So, hence Laplace of e ki power a t into f t is nothing but f of p minus a. So, you simply replace p by p minus a. Now, the second translation or the shifting property is, if Laplace transform f t is f p and g t is given as f of t minus a when t greater than a and 0 when t less than a, then Laplace transform of g t is nothing but e ki power minus a p times f p. Again we can prove this using the definition of Laplace transform. Laplace transform of g t is nothing but, we have to prove this result. So, this is equal to 0 to infinity e ki power minus p t g t dt by the definition of Laplace transforms. This is equal to 0 to a e ki power minus p t g t dt plus a to infinity e ki power minus p t g t dt. Now, 0 to a g t is 0, because g t is 0 when t less than a. So, it is 0. So, this quantity is 0 plus, because g t is 0, so integration value will be 0 plus. So, this is a to infinity e ki power minus p t when t is greater than a. So, gt is f t minus a. So, you simply take f of t minus a here gt. Now, this expression, so therefore what is Laplace of gt? Therefore, Laplace of gt will be nothing but, from here we got a to infinity e की power minus pt f of t minus a into dt. Now you can take dA minus a equal to some new variable, say z. So, dt will be dz. So, this will be equals to, when t is a, so z will be 0. When t is tending to infinity, z tending to infinity, e की power minus p. T from here is a plus z. So, it is a plus z times fz into dz. So, this is nothing but, since e की power minus p is free from z, we are integrating it with respect to z. So, we can take it outside the integration, e की power minus a p 0 to infinity e की power minus pz fz dz, which is same as e की power minus a p. So, this is nothing but Laplace transform of f t or f z. So, this is f p. This is nothing but Laplace transform of f t. So, e की power minus a p into f p. So, hence Laplace of g t is nothing but e की power minus a p into f p. So, this is called second translation or shifting property. Now, to how we can solve problems based on this, let us solve few examples on this. The Laplace transform of t cube e की power 3t. So, we have just discussed that if Laplace transform of f t is f p, then Laplace transform of e की power a t into f t is nothing but f of p minus a. So, here f t is t cube. If you compare this with this, so here f t is t cube. So, what is Laplace transform of t cube? It is gamma 4 upon p की power 4. This is nothing but factorial 3 upon p की power 4, which is nothing but 6 upon p की power 4. So, 6 upon p की power 4. So, this is f p. Now, you have to compute Laplace transform of e की power 3t into t cube. So, you simply replace f p in f p, p by p minus a, and a here is 3. So, that is nothing but f of p minus 3. So, that is nothing but 6 upon p minus 3 की power 4. So, that will be the Laplace transform of t cube e की power 3t. Next problem, suppose the next problem is e की power minus 4t cos hyperbolic 2t. So, again here if you compare with this, so f t is cos hyperbolic 2t. So, first find Laplace of cos hyperbolic 2t, let us put equal to f p, and then replace p by p minus a. Here a is minus 4. So, replace p by p plus 4. So, what is Laplace transform of cos hyperbolic 2t? We already know that Laplace transform of cos hyperbolic at is p upon p square minus a square. So, it is p upon p square minus 4. So, Laplace transform of e की power, so this is f p, this is f p. So, Laplace transform of e की power minus 4t into cos hyperbolic 2t will be nothing but f of p. You replace p by p minus a is minus 4. So, p plus 4. So, that is nothing but p plus 4 upon p plus 4 whole square minus 4. So, that this will be the Laplace transform of the e की power minus 4t cos hyperbolic 2t. Now, the third problem, suppose we want to solve the third problem, it is e की power minus t sin square t. So, first find Laplace transform of sin square t, put it equal to fp and replace p by p minus a, and here a is minus 1. So, replace p by p plus 1. So, first find Laplace transform of sin square t. So, sin square t is nothing but 1 minus cos 2t by 2. So, this is nothing but 1 by 2 Laplace transform of 1 minus 1 by 2 Laplace transform of cos 2t. So, Laplace transform of 1 is 1 by p minus 1 by 2. Laplace transform of cos 2t is p upon p square plus a square. So, p upon p square plus 4. So, this whole is fp. Now, Laplace transform of e की power minus t sin square t will be nothing but f of, you replace p by p minus a is minus 1. So, that is p plus 1. So, that is nothing but 1 upon 2 p plus 1 minus p plus 1 upon 2 into p plus 1 whole square plus 4. So, that will be the Laplace transform of e की power minus t sin square t. Again, in the last problem we can use shifting property, because what is, it is sin hyperbolic 3t into cos square t. It is nothing but Laplace of e की power 3t minus e की power minus 3t by 2 cos square t. So, it is 1 by 2 Laplace transform of e की power 3t cos square t minus 1 by 2 Laplace transform of e की power minus 3t into cos square t. So, we will find Laplace transform of cos square t, put it equal to fp, and then in the first part replace p by p minus 3, and for the second part replace p by p plus 3. So, what is Laplace transform of cos square t? That again we can find out. Cos square t will be nothing but Laplace transform of 1 plus cos 2t by 2. So, that is nothing but 1 by 2. Laplace transform of 1 is 1 by p. So, that is 1 by p plus 1 by 2. Laplace transform of cos 2t is p upon p square plus a square. So, p upon p square plus 4. So, this is fp. Now, what is Laplace transform of this e की power 3t cos square t? This is nothing but f of p minus a. And what is Laplace transform of e की power minus 3t cos square t? This is nothing but f of p plus 3. So, substituting these two values, you replace p by p minus 3 for the first part, and you replace p by p plus 3 for the second part, and you substitute these values here. So, we will get the Laplace transform of sin hyperbolic 3t into cos square t. Now, let us find Laplace transform of t sin 4t. So, sin 4t does not involve as such, does not involve e की power at, but we can break it. So, Laplace of t sin 4t. So, Laplace of t. Now, sin 4t can be written as e की power 4 eta t minus e की power minus 4 eta t upon 2 eta. This is how we can replace sin 4t. Now this is nothing but 1 by 2 I Laplace transform of t into e की power 4 iota t minus 1 by 2 I Laplace transform of t into e की power minus 4 iota t. So again here A is 4 iota if you compare with this, and here A is minus 4 iota. So you find Laplace transform of t first, let it put equal to fp, and for the first expression replace p by p minus 4 iota, and for the second expression replace p by p plus 4 iota. So what is Laplace transform of t? What is Laplace transform of t? Laplace of t is nothing but 1 by p square. It is equals to fp, and for this part it is nothing but 1 upon 2 iota f of p minus 4 iota minus 1 by 2 iota f of p plus 4 iota by this shifting property. So this is nothing but 1 upon 2 iota. What is f of p minus 4 iota? 1 upon p minus 4 iota whole square minus 1 upon p plus 4 iota whole square. So you simplify it, 1 upon 2 iota into, so this will go here, this will go here, you simplify it. So this is nothing but 2ab, 2 into 4 iota into p, 2ab into 2 again, 2 again comes, then it is nothing but p square plus 16 ka whole square. This 2 iota will cancel with 2 iota, and this is nothing but 8p upon p square plus 16 whole square. So this will be the Laplace transformation of t sin 4t. Now this problem on shifting property, Laplace transform of e की power minus 2t sin under root t. So again first we find out Laplace transform of sin under root t, and using shifting property we will replace p by p plus 2, because here a is minus 2. So what is Laplace transform of sin under root t? Let us see. So what is sin theta? Sin theta is theta minus theta cube upon factorial 3 plus theta की power 5 upon factorial 5 and so on. What is sin under root t? Sin under root t will be t की power half minus t की power 3 by 2 upon factorial 3 plus t की power 5 by 2 upon factorial 3 factorial 5 and so on. Now what is Laplace of sin under root t? Will be nothing but Laplace transform of this entire expression, and by the linearity property we can split in term wise. So this is nothing but Laplace transform of t की power half minus 1 by factorial 3 Laplace transform of t की power 3 by 2 plus 1 by factorial 5 Laplace transform of t की power 5 by 2. So this is t की power half is gamma 3 by 2 upon p की power 3 by 2. Using Laplace transform t की power n minus 1 by factorial 3, it is gamma 5 by 2 upon p की power 5 by 2 plus 1 by factorial 5 gamma 7 by 2 upon p की power 7 by 2 and so on. So this is gamma 3 by 2 is because gamma n plus 1 is n gamma n. So gamma 3 by 2 will be half gamma half, and gamma half is under root pi. So it is 1 by 2 under root pi p की power 3 by 2 minus 1 by factorial 3, it is nothing but 3 by 2 1 by 2 under root pi, again by the property of gamma function p की power 5 by 2 plus 1 by factorial 5, it is 5 by 2 3 by 2 1 by 2 under root pi p की power 7 by 2. So what finally we get? So Laplace transform of sin under root t this will be nothing but. Now you can take 1 by 2 under root pi upon this quantity common from all the terms. So this is 1 by 2 p ki power 3 by 2 into under root pi. Inside bracket we get 1 minus. So this is factorial 3 is 3 into 2 into 1, 3 cancels out, under root 2 this we have taken common. So this is nothing but 1 by 2 square into p whole power into upon 1 factorial, because 1 2 comes from here, 1 2 from here, 1 2 is common, so it is 2 square. From here 5 into 5 cancels out, so it is nothing but plus 1 by 2 square p whole square upon factorial 2, this comes. When you simplify 5 cancels out, 3 also cancels, so we will get 2 square whole square upon factorial 2, and this is under root 2 p ki power 3 by 2, and it is nothing but e ki power minus 1 by 4 p. So that is the Laplace transform of sin under root t. So this is fp, and to find Laplace transform of e ki power minus 2t, you simply replace p by p plus 2 in this expression. This is fp, you replace p by p plus 2, so you will get Laplace transform of this quantity. Again using second translation property, we can easily find out Laplace transform of gt, because if we compare with second shifting property, second translation, so Laplace transform of ft is fp, then Laplace transform of gt is e ki power minus ap times fp by second translation property. So if we compare with this, here in the first problem, what is gt? What is ft minus a? Now f of t minus a, for the first problem ft will be t cube, then only it is t minus a is 1 whole cube. So what is Laplace transform of ft? It is nothing but factorial 3 upon p ki power 4, that is 6 upon p ki power 4. Now the Laplace transform of this gt will be nothing but e ki power minus as, e ki power minus ap, a is 1 here, ap into fp, and fp is this quantity. So this is nothing but e ki power minus p, e ki power 6 into e ki power minus p upon p ki power 4. So this will be the Laplace transform of the first problem by the second translation property. Again for the second part, you see that here ft is this quantity. If you compare with this property, here ft is the ft given here in this term. So ft here is cos t. So Laplace of cos t is p upon p square plus 1. So Laplace of this ft will be nothing but, using second translation property, Laplace of ft will be nothing but e ki power minus ap, a is 2 pi by 3, e ki power minus 2 pi by 3 into p into Laplace of cos t. Laplace of cos t is nothing but p upon p square plus 1. So this is how we can find out Laplace transform of these problems using second translation property. Now the same shifting property also hold for inverse Laplace transforms. Inverse Laplace, if inverse Laplace of ft is fp, then inverse Laplace transform of p minus a is e ki power at into ft. And the second shifting property states that if Laplace inverse of fp is ft, then Laplace inverse of e ki power minus ap into f p is nothing but f of t minus a when t greater than a, 0 when t less than a. This is by the shifting property itself. Now, based on this, let us try to solve these problems. So, the first problem is Laplace of 3p upon plus 2 upon p square minus 2p plus 5. So, Laplace of this is 3 times p upon p square minus 2p plus 5 plus 2 times Laplace, oh Laplace inverse, it is Laplace inverse, yeah. So, it is Laplace inverse of 1 upon p square minus 2p plus 5. So, it is 3 Laplace inverse of p upon, it is p minus 1 whole square plus 4, it is 2 times Laplace inverse of 1 upon p minus 1 whole square plus 4. Now, here p minus 1, so you subtract 1 and add 1 here. So, this is 3 Laplace inverse of p minus 1 upon p minus 1 whole square plus 4, and 3 into 1 upon this quantity plus 2 into 1 upon this quantity will be 5 times Laplace inverse of 1 upon p minus 1 whole square plus 4. Now, now we know that if Laplace inverse of fp is ft, if this happens, then Laplace inverse of fp minus a will be nothing but e की power at into ft by the inverse property of shifting property. Now, here if we use this definition fp minus a, here a is 1, so it is nothing but 3 e की power at, a is 1, so it 3 into e की power t, and ft will be Laplace inverse of fp, so it will be Laplace inverse of p upon p square plus 4. And you replace p by p plus 1, okay, so it will be p upon p square plus 4, so that will be Laplace inverse of this quantity. Again plus you replace p by this property, it is nothing but 5 into e की power t Laplace inverse of 1 upon p square plus 4. So, this is nothing but 3 into e की power t, this is cos 2t plus 5 into e की power t, you divide multiply by 2, so it is 2 upon this, so that is sin 2t. So, that will be the Laplace inverse of this expression, that will be Laplace transform of this expression. Similarly, when you apply the same thing in second problem, Laplace inverse of this, so it is 2p plus 1, okay, it is 1 upon under root 4p plus 5, second problem. So, you take 4 common first, so it is 1 by 2 Laplace inverse of 1 upon under root p plus 5 by 4. Use this shifting property. Now, here a is minus 5 by 4, so it will be 1 by 2 e की power minus 5 by 4 t Laplace inverse of 1 by under root p by the shifting property of for inverse Laplace transforms, and this is again is equal to 1 by 2 e की power minus 4 by 4 5 by 4 t. We know that now for to find Laplace inverse of this expression, we know that Laplace transform of t की power n is nothing but gamma n plus 1 upon p की power n plus 1. So, Laplace inverse of 1 upon p की power n plus 1 is nothing but t की power n upon gamma n plus 1. So, replace n by minus half. So, it is t की power minus half upon gamma half. So, that is nothing but 1 by 2 e की power minus 5 by 4 t, 5 by 4 into t into 1 by under root pi into t. So, that will be the Laplace inverse of this expression. Now, to solve the last problem, we can use partial fractions. We use partial fraction to simplify this, and then we apply the shifting property to find out the Laplace inverse of this expression. The third problem we can solve. Now, to find out Laplace inverse of these two problems, again we will use second translation property for inverse Laplace transforms. First we will find Laplace inverse of, here we have problem e की power minus p pi by 3 upon p square plus 1. So, first find Laplace inverse of 1 upon p square plus 1. So, that is nothing but sin t. Now, using second translation property, Laplace inverse of e की power minus p pi by 3 upon p square plus 1 will be nothing but sin t minus pi by 3 when t greater than pi by 3 and 0 when t less than pi by 3. And this is because by the second property, by the second translation property, we have seen that Laplace inverse of this quantity is nothing but f of t minus a when t greater than a and 0 when t less than a. Here a is minus, here a is pi by 3. So, you replace t minus pi by 3 in this f t, this is f t, this is f t. Okay. Now, for the last problem, again we will first find Laplace inverse of p plus 1 upon p square plus p plus 1, and then using second shifting property we will find Laplace inverse of the entire expression. So, what is, so first we will find Laplace inverse of this expression p plus 1 upon p square plus p plus 1, we will call it f t, and then for this entire expression we replace t by t minus pi. The Laplace inverse of this will be nothing but minus p pi, this will be nothing but f of t plus t minus pi when t greater than pi and 0 when t less than pi. So, this we can obtain by using second property. So, Laplace of inverse of this we can find making perfect square in the denominator. Let us try to make it. This is p plus half whole square plus 3 by 4, and this is nothing but Laplace inverse of p plus half upon p plus half whole square plus 3 by 4 plus 1 by 2 Laplace inverse of 1 upon p plus half whole square plus 3 by 4, and it is e की power minus 1 by 2 t by using shifting property. P plus half is 1 and it is 1 by 2 square plus, yeah, it is okay. E की power a t, a is minus half t, Laplace inverse of p upon p square plus under root 3 by 2 whole square plus 1 by 2 e की power minus 1 by 2 t, Laplace inverse of 1 upon p square plus under root 3 by 2 whole square. Now, this we can find out, this is nothing but cos a t, a is under root 3 by 2, you multiply and divide by this quantity here, this will be nothing but sin a t, sin a is under root 3 by 2. So, that will be f t and you replace you substitute f t here. So, you will get Laplace inverse of this expression. So, thank you very much.